Welcome to our podcast, where we dive into the fascinating world of inductive reasoning. If you're eager to learn how we can draw conclusions based on patterns and observations, you're in the right place. Don't forget to subscribe for free educational content that empowers learners like you. Together, let's embark on a journey to strengthen our reasoning skills and look at the world through a critical lens. Inductive reasoning is a powerful tool that allows us to make general conclusions from specific observations. Unlike deductive reasoning, which guarantees truth based on premises, induction embraces the uncertainty of probabilities. When we observe the sun rising every morning, we conclude it will rise again tomorrow. This isn't guaranteed, it's a strong inference based on consistent experience. Every scientific discovery begins with inductive reasoning, where patterns in data lead scientists to form theories about the world around us. Think of it as the engine behind discovery, gathering evidence, identifying trends, and proposing ideas. But it's essential to remember that while these conclusions are based on probability, they are still not certain. This is where the saying "all models are wrong, but some are useful" comes into play. Understanding the limits of induction can help us navigate our conclusions more effectively. Humans have an inherent drive to identify patterns, and we utilize inductive reasoning naturally, often without realizing it. For example, if you've seen many white swans, it might lead you to conclude all swans are white. This is classic induction. However, the discovery of black swans in Australia in 1697 showed us that a single counterexample can overturn an entire belief. This phenomenon inspired the term black swan in various contexts, notably in finance, where unexpected events can have significant consequences. Inductive reasoning is vital for survival. Our ancestors relied on it to predict animal migrations, assess plant safety for consumption, and anticipate seasonal changes. Nevertheless, not all inductive arguments hold equal strength. The quality, quantity, and diversity of evidence shape the credibility of our conclusions. For instance, if thousands of clinical trials demonstrate a vaccine's effectiveness, we have considerable inductive evidence supporting its use. On the flip side, drawing a conclusion from a small, biased sample would lead to weak inductive reasoning. This need for reliable evidence is why polls strive for representative sampling, otherwise, we might reach misleading conclusions about larger populations. Renowned philosopher David Hume argued that the foundation of induction is shaky because it assumes the future will mimic the past. This dilemma is known as the problem of induction and continues to prompt philosophical debates. The scientific method exemplifies inductive reasoning's role in forming laws and theories. Scientists observe phenomena, gather data, detect patterns, and propose explanations, as seen in Charles Darwin's research on finches in the Galapagos Islands. His observations led to the prevailing theory of evolution by natural selection, showcasing the strength of inductive reasoning when supported by substantial evidence. It's interesting to note that scientific theories are never entirely proven in the deductive sense. Instead, they continually evolve, adapting to newly acquired evidence, a hallmark of the scientific approach. This self-correcting nature is what makes science robust. It persists in refining conclusions based on fresh insights. While inductive reasoning is invaluable, our tendency to see patterns where they don't exist can lead to inductive bias or apophenia. This inclination can result in superstitions, false beliefs, or conspiracies. For example, if you've worn the same pair of lucky socks 3 times when your favorite team won, you might mistakenly attribute their victory to the socks. An infamous incident occurred in 1942 when the German military misused pattern analysis to assess bomber effectiveness, leading to flawed decisions due to survivor bias. To strengthen our reasoning skills, we must consider all evidence, avoiding the trap of only acknowledging what confirms our preconceptions. Analogical reasoning serves as a specialized form of induction, allowing us to draw parallels between different situations. For example, if a new smartphone resembles a dependable older model, you might conclude it will also be reliable. This method has historical roots. Johannes Kepler used analogous thinking to relate the moon's effect on Earth to how magnets attract iron, contributing to gravity theory development. However, like all inductive reasoning, the strength of an analogy hinges on the relevance and number of similarities. Understanding real-life applications of inductive reasoning is invaluable. Each day, we employ it subtly in our decision-making processes. Choosing a restaurant based on online reviews reflects inductive reasoning. Past positive feedback suggests you might have a pleasant experience too. If dark clouds loom and you remember it rained during similar weather before, that's another instance of induction in action. Additionally, your trust in a friend's movie recommendation is shaped by their reliable tastes in the past. The insurance industry illustrates inductive reasoning in practice. Actuaries analyze historical data about risks to predict future outcomes. While they can't foresee individual accidents, they can assess probabilities effectively. This underlines the potency of induction in shaping our everyday choices and its role in navigating life's uncertainties. Despite its merits, common inductive fallacies can derail our reasoning. The hasty generalization fallacy occurs when we conclude based on scant evidence, like labeling everyone from a city as rude because we met just 2 rude individuals from that location. The cherry-picking fallacy happens when we only consider data that supports our belief, ignoring conflicting evidence. A historical example: in the 19th century, medical professionals dismissed hand-washing's effectiveness in reducing infections, believing illness stemmed from bad air. This exemplifies confirmation bias, where we accept evidence that aligns with pre-existing beliefs. Lastly, there's the gambler's fallacy: just because a coin has landed on heads 5 times, it doesn't mean tails is due to appear next. Each flip is an independent event. Recognizing these common pitfalls is vital for enhancing our critical thinking abilities. Building robust inductive arguments is crucial and can be summarized in 3 guiding principles. First, gather ample evidence. More data generally translates to stronger conclusions. Next, ensure your evidence is representative and diverse to avoid bias. Lastly, entertain counter-evidence. Actively seeking information that could disprove your conclusion leads to deeper insight. For instance, if you're studying the mental health benefits of exercise, you would want to include not only those who exercise regularly but also individuals who abstain or have different health conditions. The scientific community employs a standard called statistical significance to determine when evidence is sufficiently strong. Typically, it's set at a 95% confidence level, implying only a 5% possibility of the observed pattern being due to random chance. This makes induction not just a philosophical discussion but a practical application to make sound judgments. Mastering inductive reasoning involves embracing the nuances of probability instead of seeking absolute certainty. Successful scientists, detectives, and decision-makers recognize that induction offers the best conclusions based on available evidence but remain open to new data and insights. For example, when doctors diagnose patients, they utilize probabilities based on symptoms. The most likely diagnosis guides initial treatment, adjusting as necessary based on patient responses. The advent of modern statistics revolutionized inductive reasoning in the 19th century with figures like Francis Galton and Carl Pearson, who developed quantitative measures for correlation and probability. Today, even advanced technologies like machine learning and artificial intelligence rely heavily on inductive principles, analyzing vast datasets to draw insights and make predictions. This highlights that induction expands far beyond theoretical concepts. It serves as the very foundation of contemporary technology. In this episode, we explored the realm of inductive reasoning, learning how we can draw general conclusions from specific observations while understanding the important nuances and potential pitfalls of this method. We discussed the key role inductive reasoning plays in the scientific method, the everyday decisions we make, and the valuable criteria for building strong arguments. We also enlightened ourselves about common fallacies that can cloud our judgment. By applying what we've learned, we can refine our thinking and decision-making skills, making us better problem solvers in all areas of life. Thank you for joining us today. We hope you found this discussion on inductive reasoning insightful and inspiring. Remember, each observation is an opportunity to understand our world better. If you enjoyed this episode, please subscribe for more enriching content and share it with others looking to sharpen their reasoning skills. Until next time, keep questioning, keep learning, and stay curious.